All right, hello and welcome. So, we've already talked about how to create our own functions, right? Well, today, we're going to unlock a keyword that gives those functions a genuine superpower, and that keyword is return.
Think about it. We know functions can do stuff, like blink an LED or print something to the screen. But what happens when you need a function to figure something out and give you the answer back? How does it hand that result back to your main code? Well, that's the exact puzzle that the return keyword is built to solve.
Okay, so let's dig in. The return keyword, it's kind of cool because it has two very different but super powerful jobs. I like to call them its two superpowers. First, it can be like an emergency stop button, and second, it can be a messenger, carrying data for you. We're going to break down both of these one by one. First up, let's check out return in its most basic form, just as a stop sign. This gives you some really precise control over how your functions run.
And honestly, it's as simple as it sounds. The second your code hits that return keyword, boom, it's out. It immediately leaves the function and jumps right back to where it was called from. And any code that comes after that return line, it's just ignored. It'll never, ever run.
This here shows that flow perfectly. Your code is just chugging along line by line. It runs statement 1, then statement 2. But the moment it hits return, that's it. Game over for that function. It won't even glance at statement 3.
And here's what that looks like in some actual code. If you were to run this, you'd look at your serial monitor, and all you'd ever see is, this is statement 1, and this is statement 2. That third print line might as well not even be there, because return acts like a brick wall, guaranteeing it's never reached. Okay, so that's the stop sign. Simple enough. But now, let's get to the second power, which is, well, it's where things get really interesting. This is how we get our functions to talk back to us and actually deliver results. So, to make this work, we have to understand this thing called the return type. Now, you've probably seen void written before our function names a bunch of times. That literally just means this function returns nothing. It does its job, and that's it. But what if we wanted to return a whole number? Well, we just change void to int. Or if we want a decimal, we use float. It's like making a promise. The function is now promising it will send back a value of that exact type. Let's take a look at this add numbers function. See how it starts with int? That's our promise. We're telling the program, hey, this function is going to give you an integer back. So it takes in two integers, adds them up, sticks the result in a variable called sum, and then here's the key part. It says return sum to send that final number back out. So how do we actually use this thing? Well, back in our main loop, we can create a new integer variable, let's call it added value, and we set it equal to the result of our function add numbers 4, 5. What happens then is the program pauses, jumps over to the add numbers function, does the math, 4 plus 5, and then it sends the answer back, and that answer gets stored right inside our added value variable. Pretty slick, right? And the value it sends back is, you guessed it, 9. The most important idea to really get here is that the code add numbers 4, 5 doesn't just run, it actually becomes the number 9. It's like it gets replaced by the value that the function returned. Now, all this theory is fine and dandy, but let's see how return can make a real-world hardware project so much cleaner and, honestly, a lot more powerful.
Okay, here's the mission. We've got a potentiometer, a little knob we can turn. We're going to read its value. And if that value goes above 400, we turn on an LED. If it's 400 or below, the LED goes off.
Super simple. And this, right here, is the magic. This is why we do it. On the left, you see the old way. All that logic is just jammed right into our main loop. Yeah, it works, but it's kind of cluttered, right? But look at the right. By using a function with return, our main loop is now just one single, beautiful line of code. It's so much cleaner and way easier to read at a glance. So how do we do that? Well, this little function is doing all the heavy lifting. We made a check sensor function. It reads the potentiometer, and if the value is over 400, it returns a 1, which Arduino sees as high. If not, it returns a 0, which is low. All that if-else mess is now tucked away neatly inside its own little box. So, as you can see, return is an absolutely essential tool for writing code that's clean, that's modular, and that's powerful. Let's just do a quick recap of its two main gigs. Just remember those two superpowers. It can be a stop sign to get out of a function early, or it can be a messenger, delivering a specific value right back where you need it. And of course, the golden rule. Whatever type you promise to return, you gotta send back a value that matches that type.
So by bundling up your logic inside functions that hand values back, you're making your main code so much cleaner, so much easier to read, and a whole lot more reusable. So the real question I have for you is, what part of your next project are you going to clean up using the return keyword? Think about it. Thanks so much for tuning in.